This screencast is about the octet rule and covalent compounds forming molecules. Okay, there are several types of bonding. You can have ionic, metallic, and covalent, so we're going to focus on covalent bonds. And a covalent bond is when you are sharing electrons, meaning no one element is gaining or losing, but the electrons are being shared between two elements. And those two elements, or those two electrons being shared in between, is an example of a bond. So you can have a molecular compound, which is a neutral group of atoms that are held together by a covalent bond, and that's a molecule. An example of a molecule would be H2O or CO2. And a molecular compound is a compound whose simplest units are the molecules. So you see in this diagram here, you have water molecule, an oxygen molecule, and a sucrose molecule. And they are in their simplest form. And you can see where all the different atoms are combined and in what order. So you have molecular compounds, and you can have a chemical formula and a molecular formula, and they can be the same. You will see the same things in both. You're going to see, for instance, how many carbons and hydrogens and oxygens you would have in a compound. But the difference is, in a chemical formula, you are going to see the subscripts, like it wowould be C2H3O2 or something like that. And a molecular formula shows you how they're all combined together in a single molecule. So there's one rule that governs all covalent bonding. Every atom wants to have a stable configuration, and to do that, they need to have a filled outside energy level, and that's called the octet rule. So each element is trying to share electrons in order to achieve a noble gas-like configuration, and that's so that they're stable. You either have 8 electrons in your outer ring or 0, meaning you've gone into an inside ring. So the octet rule says that noble gas atoms are unreactive because their electron configurations are especially stable, and other atoms can fill their outermost s and p orbitals by sharing the electrons through a covalent bond. And such bonding forms by the octet rule, meaning the chemical compounds tend to form so that each atom is gaining, losing, or sharing electrons, and they have 8. So in the S, remember, in the S section you can have 2 electrons, and in the P section you can have 6, and together that will give you 8. So the magic rule is octet, which is the prefix for 8. Now, just like everything else in nature, you can have exceptions. While the goal is to achieve 8 electrons in their outer energy level, sometimes, if you jump down here to this last bullet, sometimes you can have more than 8. You will see 10 and 12, and this is in the 3rd period and higher, which on the periodic table is actually lower on the periodic table. So it would be in the 3rd row, 4th row, 5th row, 6th row, etc. These elements can gain an extra pair or 2 extra pairs and have 10 or 12 electrons around their center atom. And then there's hydrogen, which will only ever have 2 electrons. It's in the 1st energy level, and so it only has an S section to fill, and the S section can only have those 2 electrons, so that's why hydrogen will only ever have 2 dots around it, or 2 electrons. So remember, the goal of the octet rule is to have 8 electrons. Hydrogen will only want to have 2, and any row from the 3rd and lower can have 12 electrons or 10 electrons. That'll be key for helping you as you go through. And remember, the reason is all about stability.